Hello and welcome to yaymath.org and Yaymath in Studio. I'm standing in YouTube's Hollywood, not Hollywood. I feel like I'm in Hollywood. I'm in Los Angeles, and this is the YouTube space in LA. It's the YouTube headquarters, basically. It's a Google facility where YouTube creators, such as me and the people next door, can come in and create videos and create content so that we could add to our libraries and create more things for people like you that are watching this stuff. So I'm so happy that you're here and that you're watching this. I hope to help you, and I hope to share my love of math and my love of connecting with people with you today. So yay math, as we jump into literal equations and dimensional analysis. Now that's a mouthful, but essentially what it is I'm going to give you a bunch of equations and we're going to solve for variables within those. That's what that means. So literal equation, like, let's say if I said 4x minus 3y equals 8. Now this looks like the equation of a line, it turns out, okay? And what if I were to make this x black for a second? Boom, boom, there it is. And so could we isolate x using rules of algebra discussed in other videos? We totally can, all right? The idea to isolate x is we need to move stuff away from it. We need to get x alone at the party because x is not really being kind and everyone just sort of like, oh, I don't know what that guy's problem is and like sort of move over here. And so the first thing to go would be this minus 3y. The question is, what's in the way of x being by itself? Why is x not by itself? First, it has to do with this 3y, negative 3y. So I could add 3y to both sides. Observe. Boom, boom. Boom, boom. Down. And we're left with 4x equals. Now it doesn't matter the order we put this in. We could do 8 plus 3y. That's fine. 8 plus 3y. And we are one step away for getting x by itself. We can divide both sides by 4. Divide both sides by 4. Like there it is. These go. And now we get x equals. So check it out. 4, 8, and 3 do not share a common factor. So in a sense, this would be fine as our final answer. I could say 8 plus 3y over 4. If I insisted on dividing by 4, though, this 4 would have to divide into both terms in the numerator, both terms upstairs. So in a sense, I would have to do 1 and 2. Right? So let's hit 8 over 4, or 8 divided by 4. So I could say, or, I'll take that off, just so you could see it. There you go. And then let's take this off. Lovely. Yeah, okay. All right. So now you know what to do. So 8 goes into the 4 2 times, plus, or 4 goes into the 8 2 times. And then we have 3y divided by 4, so we could just say that, 3y over 4. So either one of these are acceptable, okay? Some people prefer this. I actually prefer this one, you know. The idea of why I like this more is that because we can't simplify any further, we just stop. We just stop and walk away from the problem. Can't simplify further, so leave it alone, all right? Let's try another literal equation in which we can solve for variable. I'll give you this same equation twice, solving for different things. The first one we're going to solve for is the a. So here, solving for a. So the question is, why is a not by itself? It's this b plus 4. In fact, we can cue our minds. That's a times, a times b plus 4. What would we need to do to both sides to get a by itself? Well, since we are multiplying a by something, we can divide that something so that it cancels. So we can divide by the very thing we want to cancel, in this case, b plus 4. Check it. Check it. Here we go. b over 4 plus itself is 1. These go. And we are done with the problemo. This is a over, or a equals, I should say, 10 over b plus 4. There you go. This does not simplify further either. okay? b plus 4 is a single factor, and nothing about b plus 4 would cancel with 10. Not even the 4. It's tied as one denominator. We are going to solve for the b. Now let's get b alone. We got a alone. Now let's get b alone. All right. How do we access it? How do we get inside here? The only way I could think of is to distribute the a. So we're going to rock that. To distribute the a means a multiplies by the b and multiplies by the 4. So we can remove the need for these parentheses there. So here we go. 10 equals a times b is ab. A times 4 is plus 4a. All right, we're solving for b. We're solving for b. Here's b again. I like to put a little dot so I know what I'm looking at. What can I do to both sides? I think this minus 4a on both sides. That's like a quick fix to the problem. Minus 4a, minus 4a. There we go. These go. And we're left with, I'm going to bring ab on the left so that we know we're solving for it. ab equals 10 minus 4a. And then, again, we're solving for b. There it is. So I can divide both sides by the very thing I want to cancel. That's a funky a. Let's fix it. There it is. A over itself is 1. Solving for b. So again, so you have b equals 10 minus 4a over a. Again, we could leave it that way because a is not a common factor for everything. Or if we insisted on dividing into both terms, we could say, or a goes into here, and then a goes into here. Interesting, minus, definitely minus. 4a divided by a. 4a over a is just minus 4. So either one of these are sweet for us, all right? So that's the idea, is using rules of algebra. It doesn't matter if they're numbers or not, to just cancel stuff and move it to the other side so that we can get a variable alone. This one gives students a lot of trouble, problems like this, because I'm about to ask you to solve for x. Now, if I wanted to solve for x, check it out. I can't eventually combine 3x and cx, except maybe in a rhyme. The 3x and the cx. See what I mean? I'm trying to find x. Can do it that way. Can combine them in a lyric, but they can't really combine mathematically. So we need tools. That's why we're here. Give you the tools. All right, so first step, at least we could bring the x's all to the left, and we could bring the stuff that's not x to the right. So I'm feeling in my soul minus cx on both sides. Let me take this off, yeah, for clarity. Minus cx on both sides. These can go. And in fact, let's do some red here. The red in the house. Let's move that 4y. Opposite of minus 4y is plus 4y. Bring that over. Plus 4y, bring it over. Boom. Okay. Let's see what's left as the dust settles. 3x minus cx. 3x minus cx equals, all that's gone, this is gone, 6 plus 4y. 6 plus 4y. Now here's that issue, like more, visible, that we can't combine these x's into a single term if we're trying to solve for x. So I'll just put that down so we have it, solve for x. There we go. So we need to think of tools similar to what we talked about previously. We use this thing called distributive property, okay? Maybe you know distributive property. Distributive property has this little this thing, a and times b, or a plus b. And then you're like throwing it in, boom and boom. So that's the same as box A plus box B, if you will. So that's cool. But interesting, can you go from box A plus box B to the thing that's under my arm, could you undistribute? You do distributive property in rewind. So Jim Carrey homage. Anyway. So yeah, I bet you can, especially because I moved my arm. There, see? To undistribute has a fancy name. It's called factor, okay? To factor is breaking things down into pieces that multiply. So if we notice, this box is multiplying a plus b. So if I could pull the factor, or the piece that multiplies, outside of the a plus b, so I like bring it out here. So I'm going backwards in time here. Boom. Undistribute. So box times what is a, or box times what is box A, I should say. Box times what is box A? A. Plus. Box times what is box B? B. That's called factoring, right? There's plenty of other videos on factoring, but this is a fun little, this is what it is, basically. This is what factoring is breaking it into pieces that multiply. And that will serve us here. Do you see that x is a factor of 3x? Do you see that x is a factor of negative cx? So let's undistribute x. Pull x out. Do distributive property backwards. Boom. And I'll ask the same questions I asked over here, all right? The question is, x times what is 3x? X times what is 3x? Well, 3. Look at it after the fact. Is x times 3 3x? Yes. Minus x, bring the red back. X times what is negative cx, or minus cx? X times what is cx with a minus? None other than c. Look at it after the fact. What is x times negative c? Negative cx, right? We could just put, we can change the order using commutative property. And then we continue on with the problem, and notice now we've reduced our 2 instances of x down to 1, equals 6 plus 4y. What is the opposite function of x times? Divided by. Hook it up. What is the thing we need to divide by to get x completely by itself? This factor, this piece that multiplies. So we're going to divide to counteract the times, gauni, over 3 minus c. And so this is done. This doesn't simplify any further. There are no common factors between 3 minus c and 6 minus 4y. So we have x equals this thing. I'm going to write it to be formal. 6 plus 4y over 3 minus c. So that's a beast of a problem. Just remember, if you can't combine like terms, you can factor out the thing that you're looking for. In this case, we factored out the common x between them. I'll leave it. Okay. All right, good. So let's solve for r. Okay. Now, sometimes the confusion of solving for r is like, oh, divide by 2. We could do that. I'll even write it. If you divide both sides by 2, r still won't be by itself yet. It'll be pi r still. So maybe we could divide by more than just 2 to cancel both things. This is 2 times pi times r, so we could divide by the 2 pi itself. There it is. So if we divide both sides now by 2 pi, 2 divided by 2, pi divided by pi, and now we successfully got r by itself. I'm going to bring it on the left. R equals c over 2 pi. There you go. Same concept over here. What do you want to solve for? We could solve for w. Doesn't matter. We could have a little fun. Boom. There's dubs. Okay. What can we divide both sides by? To get rid of L and H multiplied. Same idea over here. Divide both sides by LH. So they go. I won't do that in red. Let's do purple here. Divide by LH. Cursive. So it doesn't look like a 1. Divide by LH. And We got this. W equals V over LH. So that's the idea. That's the idea. Let's do it more intense. Maybe here we'll solve for x. Let's do it. So the temptation, right, is to get rid of this fraction. Ooh, I want to so bad, and we will, but we can't multiply by 4 yet. Can't do it yet. A lot of people think we need to, but we shouldn't because we have to deal with this 1 first. Maybe we could just move that, just flick it over to the other side. Then we don't have to worry about distributing 4. Because if I multiplied 4 here, it would have to go to the whole side of the fraction. So 4s would cancel. That's cool. But then that 4 distributes to 1. Problem. And I'm making the problem more complicated. So rather than do that, erase with the left hand here. The left-handed layup. There we go. Like a left-handed brick. Here. Boom. Well, left-handed brick. So let's subtract 1 on both sides. That counteracts this thing. And then the fraction is isolated at least. Ax minus 2 over 4 equals 8y minus 1. Now we can cancel the fraction by multiplying by 4. And we'll see in doing that how it operates over here. It has to be done to the entire side. It must be done to the entire side. Every entity, every piece gets the 4 treatment. All right? Coming soon to a spa near you. Would you like the 4 treatment? Oh yeah, distribute it through. Let's do it. So we got ax minus 2 equals, distribute 4, 8y times 4 is 32y. Negative 1 times 4 is minus 4. We're getting there. Get x by itself. The 2. What's opposite of minus 2? Plus 2. Look it up. Boom, boom. These are like terms, so we can combine them. So we have x equals 32y. Negative 4 plus 2 is minus 2. And now finally, to get x by itself, counteract times a, boom. Look at that. Isn't that wild? Like, just look at it for a second. X equals 32y minus 2 over a. Could you have ever guessed that in this original equation, when getting this x by itself, when you throw everything to the other side, all this gone and cleaned up, it's left with 32y minus 2 over a. I'm almost like paranoid if it's right or not, but I feel like it's cool. I feel like it's fine. Distributed 4, subtracted 1 on both sides, got 8y minus 1. Yeah, I'm feeling good. Negative 4 plus 2 is minus 2. Yeah, we all can make mistakes. The process of checking is the same for me as it is for you. So I'm feeling like that's good on that one. And last one more. One more. All right. It's the old school Maryland me talking. One more. That's a Borat Maryland mix. One more. That's better. Okay, F. Solving for F. Again, our goal is to maybe clean up using addition or subtraction first, like we did here. We subtracted 1 on both sides. It simplifies the side where F is on. So that A is what we have our I on. Minus A, minus A. And we're left with X minus A equals gown minus FG. All right, we want to get F alone. F alone. What's in the way? Negative and G. And this is a multiplication. So maybe you're sensing the opposite of multiplication is division. This is gone. It's tempting to say divided by G. And that would cancel G, but we want to also cancel the negative. And as we might know, a negative divided by a negative is positive, thus canceling it. Boom. So now we have negative divided by negative is gone, canceled. G divided by G is gone. And we have F for fun is alone. I'm bringing it on the left. equals, interesting, x minus a over negative g. This is fine. This is totally fine as an answer, okay? Or that negative can apply up here. If we wanted to make that g positive, we could take the negative and put it on the top. If we did, it would apply to everything. That's also fine. We could leave it that way. Negative in the denominator is equivalent to negative in the numerator. It's just saying that the fraction is negative. And since that negative applies to the whole thing, we could leave this alone, we could leave this alone, or we could distribute the negative so that we're masterful. We're doing it all three ways. Let's have all three set up. That's one, that's two. Distribute the neg, and negative distributed to the x is minus x. Negative distributed to minus a is negative negative a. That's plus a over g. There was a very real reason I did this, is that sometimes answers are expressed in different ways, but they all are pointing to the same thing. So not to be intimidated. Let's say this is your answer, and then you check your answer in a book if you're doing an assignment, and this came up. You know, keep your hope because you got it right. Just have to know where that negative goes and how it operates when you lift it and distribute it through that numerator. All right, cool. Well, thanks for watching. Yay math, and I'll see you in the next video. Boom, 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 boom.